Alright, so this is lecture 3 where we'll talk about inverse trig functions. So make sure you submit the work and we'll be expecting the best. So I'll put a lot of questions whereby you need to practice. So without wasting our time, we can start. Alright. Alright. So we differentiate trig functions. First of all, one thing that I need to tell you is um what we need to know is that first of all I'm going to put these things in order. Okay, I'll write sine x, then here I'll write cos x, then I'll write tan x, then I'm going to write cot x. Okay, the other thing that I'll write is sec x, then I'm going to write also cosec x. Alright, so if I've written them in this order, this means that the inverse of each, it will be moving like this. So the inverse of 1 over, let's say sine, that is cosec. Again, the inverse of cos, that will give us sec. The inverse of cot, that will give us tan. Okay, so this means that 1 over sine you get cosec. Again, 1 over cos you get sec. 1 over tan you get, just like that, vice versa. So that's how we'll be mastering them, like that. Alright, so make sure that you actually understand also this part. It's very important when we'll be summarizing some of these things. Alright, alright, so that's how they'll be matching. Alright, so let me just lab this. Okay, hope you have taken note of that. Please copy if you want. They are very important, these, before I start closing. You can copy that please. So remember our title today says inverse trig functions, so the derivative of inverse trig functions. So what we need to know is that first I'll start with the sine. Alright, so suppose we have y is equal to sine inverse x. Okay, how do we differentiate this? So what we are going to do is okay, sometimes you just differentiate this. So I will equate it like this. You put y like that. Okay, if it is like this, this is the inverse. This means that sine was down there. Okay, so it had to change. So this was same as y is equal to, alright, y is equal to x over sine, just like that. So this means that we can multiply now and we get sine y is equal to x, like that. Okay, so that's the meaning there. Have you seen they have just reversed the inverse thing there on top? Simply means 1 over something. Okay, so from there, differentiating both sides, will say dy dx of sine y is equal to x. Okay, so supplying differential of everything inside. Remember I told you that whenever you differentiate y, you always attach dy dx to that function. Alright, so differentiating this is now a trig function with y as an angle. So how I said you differentiate always an angle whenever you differentiate a trig function. You start with the angle, you differentiate, then you come to the whole trig function. So differentiating y, will attach y, so that would be just 1, then dy dx. Okay, then differentiating the whole trig function now, that will give us what? Let me just do this. Let me move it like this. Differentiating the whole trig function, that will give us what? Differentiating the whole trig function, that will give us cos y. Then you always differentiate the angle. So differentiating the angle, that is just dy dx of y, it's 1. Okay, then you always attach dy dx, the same dy dx there. Okay, then is equals to the dy dx of x, that will be just 1. Okay, hope we are clear on that one. Okay, so this means that we'll have dy dx, I'll divide throughout, that will be y over, alright, cos y, like that. Okay, so we have a famous identity. So famous identity, very important identity. Let me just give you, whenever we have cos squared, let's say cos y squared plus, okay, sine, because of this y I have there, sine y squared is equals to 1. Okay, so this means that bringing cos there down there. Alright, so that will be cos squared y is equals to 1 minus sine squared y. Okay, so this squaring, since this cos is squared, so we'll square both sides. So that will be, we introduce the root on both sides like that. Okay, so that will be cos y is equal to root of 1 minus sine squared y. Alright, okay, so that means that we'll go replace there. So say dy dx is equals to 1 over this. Now what we have found there, this what we have found there, so that will be root of 1 minus sine squared y. Okay, so this final will give us dy dx of that function is equal to 1 over, alright. So when you look at this, we have 1 minus, look here at this point we had sin y is equals to x, so this is sine squared x, so we'll attach squared there because at this point it was just normal, then here it is squared, so that means we'll also square there. So this actually marks the end of the 1 over root of, yeah, so that's the derivative of sine x. So they are just the same with cos x. See, the game is still the same. Let me lab this, but this identity will still be maintained. Okay, we can lab, there's no problem. So I want you to master to say this is the differential of this one. Okay, that's what I want. Alright, suppose now we have cos inverse, alright, cos inverse x. Let me just say, okay, so we give this as a function, y is equal to cos inverse x. Alright, let me put yellow. So from there, then what we are going to do, this is same as y is equals to 1 over cos then x. Okay, so this means that we have cos y is equals to x. Okay, so supplying dy dx to everything that is inside, so that will be cos y is equals to x, like that. Okay, so differentiating everything that is inside, so you differentiate the whole function there, that will give you what? That will give you differentiating sine. By the way, let's go to our Cartesian plane. Okay, so you remember when I gave you sine x cos x, then again here we have negative sine x, then we have negative cos x there. So I said whenever you differentiate sine, you come to get coses. You differentiate cos again, you get negative sine. You differentiate negative sine, you get negative cos. You differentiate just like that. So dy dx is moving like anti-clockwise. Alright. So that's how we'll be moving. So differentiating cos y, that will give you negative, right? So we'll say, so that will be negative sine, meaning negative sine y, okay? Each time you differentiate a trig function, you also differentiate the angle. So the dy dx of the angle is just 1, but each time we differentiate a trig function y, you always attach dy dx, or just, yeah, dy dx. Alright, is equals to the derivative of x, that will be just 1. So from there, then what we are going to do is we'll say so we'll say dy dx is equal to 1 over, we divide throughout by sine y, like that. Okay, by the way, it's negative because of the negative we had there. Don't forget the negative. Alright, so from there, then what we are going to do is we'll say we'll bring the same identities. Now the sign that we are making, sine squared is equals to 1 minus cos squared y, like that. So what we are going to do is we'll root everything so that we remove a square, because we don't have a square there. So what I'm going to do, I'll say sine y is equals to alright, so sine y will say it's 1 minus cos squared y. Alright, so this is under the root. Alright, so from there we are going to replace that there. Alright, so that will say dy dx is equal to 1 negative 1 over, alright, root of, because where there is sine y we'll put this, so that will be 1 minus cos squared y. Now that, so I'll say 1 negative 1 over, alright, c. So we have cos y squared, we had cos y as is equals to x, so I'll put wherever there is cos y, I'll put what, x. So that will be 1 minus x squared, like that. Okay, so that's also marks the end. That's how you can differentiate cos inverse. Alright, let us talk about now how to differentiate. Let us talk about how to differentiate tan and sec together. Alright, so let us talk about how to differentiate sine. So that is it. You can copy this. Alright, so you meet questions after this. Or let me just do this so that I go on the, but it's okay, just see. Alright, alright, so now differentiating tan, suppose we have tan inverse x. Alright, so how do you differentiate this one? Let me use yellow. Yellow is at least visible. So what I'm going to do is, I'll say again, I'll make this as a function y is equals to tan inverse x. Alright, so this means that this is same as y is equal to 1 over, because that inverse it came as a result of 1 over something, so there then x there. All right, so we can now multiply. This means that it is tan y is equals to x when multiplying that, causing multiplication like that. Then from there, now this is what we are going to differentiate to say dy dx of, all right, tan y is equals to x, then close the brackets like that. So differentiating this, all right, so differentiating everything here. So whenever I told you that whenever I differentiate a dy dx of sec, all right, the dy dx of sec this will give you sec x, just that will give you sec x again, then tan x, then the dy dx of tan, that will just give you sec squared x. Okay, so also identify why they are coming like this. Okay, so that is it. So from here, what you are going to do is we'll arrange this. We have already arranged like that. So now we start differentiating. So differentiating this, that will give us sec squared y. Okay, then each time we differentiate that, you differentiate the angle, so that will be just 1 dy dx. Okay, then is equals to 1. Okay, because the dy dx of x is just 1. Alright, so this means that we can divide throughout. So have dy dx is equal to 1 over, okay, sec squared y, like that. Okay, so there's this identity, also a famous identity that I want to show you. We have just to know it, this one. Alright, okay, so we have sec squared x is equals to 1 plus tan x, like that. So it's like this. Okay, so always so you subtract, it's more like you move like this. So let me show you. If they are in squares, this plus this is giving you 1 if they are squared. Then sec squared minus tan, that will give you what? That will give you 1. So you have to master it in that way. So this is the identity I'm trying to show you. So master it in that way. So from there, then I'll use this identity. It is squared there, so I'll put it like that. So by the way, it is also squared there. So I'll say dy dx is equal to 1 over, so sec squared y, we can now replace there. That will be just 1 plus tan squared y. Okay, I mean x. Alright, so that will be x from our identity there. Okay, so this means that tan x, or let me just put y. Alright, yeah, I was supposed to use y identity here. Alright, okay, there's no harm though. So this means that finally we have dy, we have 1 over, alright, 1 plus, where there was tan xy squared, so now we'll square just that x there. Alright, there. So we'll just put x squared like that. You have seen? So that will be the derivative of tan inverse x, that will be just 1 over x, 1 plus x squared. Okay. What of cot? Quote also apply the same, but here it will carry a negative just like for cos. Alright, here it will be a negative. Try for quote, yes. So try for quote. It will still give the same, but you use the same identity. I think you use the same identity, but here it will give you a negative. So try for quote. I want to do it, but try it. Alright, it's just the opposite. Quote is just the opposite. So it will give you the same, but you need to put a negative somewhere because of this identity. You need to make one the subject of the formula. So try that. So this finally I can conclude to say the trig function that we have looked at. First of all, sine inverse x, this gave us, let me again write cos negative. We have also tan inverse. We have also cot inverse, like that. So what were we getting when we were doing this? Okay, so for sine we got 1 over root of 1 minus x squared, like that. Then for cos we got negative 1 over the same thing though, so we say 1 minus x squared. Then coming to tan we had 1 over x plus x squared plus 1, or 1 plus x squared. Then coming to cot, I said you just put a negative there just like for sine. Then 1 over x, alright, then plus x squared. No, 1 plus x squared. You choose either way of arranging x plus 1. So from there, those are the trig functions we have found, and make sure that you are able to actually derive. So they can put something to say sine, alright, let's say sine x, like that. So you are told to differentiate, so you just go on your identity to say 1 root of, okay, 1 minus, meaning that it was squared there, so you put there, that's the value of what you need to know. Alright, okay, it is squared, that x, so this means that that will be 1 over root of 1 minus, alright, so that is squared, that will give you just x. You have seen the way it will be somehow trick. So that's how the answer, that's the answer for this question. Okay, so those are the things involved. So they can put anything here where there's angle, where there's an angle there, they can put anything. So your duty is just to go and substitute in those identities that you have mastered, okay, where there's x there. Alright, in fact this x was supposed to be there, also there. Either way you can arrange, but know that this x comes from, so whatever the value they will put there, come and square down there. Alright, whatever value they put here, come and square down there. Okay, so that's how you'll be dealing with these. So let me show you some exercise that you need to practice. So like for this case, you do the identity, but you go square this, you find that these they will be cancelled. Okay, that is it. That's how you solve this one. Now need the answers. Also for this one here, there is a case of product rule. Alright, just here there's a product rule. There's A, there's B there, okay, B with this angle. Then there's also this part where you do the inverse thing and be able to find whether it's a quotient or what, you'll be able to figure out. Here it's also product rule. I have this and also this with the tan, okay. So you have also other things there to differentiate, okay. So this is not a quotient, but this can be differentiated as just algebra. Then here, this is a very important question, alright. So this is very important, so please make sure that you solve this one with all your effort. Then from here you also try this. Here it's just we have this function, you raise to its power, you reverse by writing 1 over 3 like that. Then here we know how to differentiate this one also. Then coming to this one also, sec inverse, this is not very important though, but I was supposed to do for sec. So for you to do sec, I think you just have to do 1 over cos, okay, 1 over cos, then you'll be able to find that. Okay, so that's how you approach this. Equal this one, equal this one. I said I demonstrated using quote. I think I've done for quote. Then for this one, this is where you go and substitute in that identity. You just go and substitute there. All right, so you go put 3x there squared, then you'll be able to find what is there. All right, so that will be 1 over root of 1 minus 9x squared. Okay, so that would be the answer for this one. I'm just showing you what is happening. Then for this one also, you go and square there where you put we have looked at the identity. So in the identity, just pretend solving this one to say suppose this is x, then you go solve and reach the identity, then substitute these values, then that will be your end there. So equal this one. These are not exam question though. Okay, this one can be exam question, but the rest also, this one can be an exam question, this can't be an exam question, and also this can't be an exam question. So but try to solve all these that I've marked. So solve this one, also solve this one, then the other one solve so solve this one, solve this one. What else? Solve this one, solve this one, solve this one, then and this one, very important. Then from there, what else? Solve this one and also this one. That's so very important. Okay, this marks the end. Thank you very much for your time. Alright, so this marks the end. Please try to attempt these questions, they are very important.